Hello, this is Dr. Ryan Johnson with Introduction to Statistics. Today we're covering section 8.3, Theory-Based Approach for Analyzing Paired Data. So in this situation, we've got an economist at Vanderbilt University who's come up with a study to look at different types of online auctions. And so he's selling some different Magic the Gathering cards. A lot of my grade students don't know what Magic the Gathering is. It's like a card game where it's popular among math nerds, but not as many Grace College students have known about it. But some cards are worth more than others, and so sometimes players sell cards to each other. So we've got two different types of auctions. A Dutch auction is a first price sealed bid auction. So every player, like everyone who wants to buy, says what they're willing to pay for the card, and whoever nobody else sees anyone else's bid, and whoever has the highest number gets it. And then that's the sealed bid one. The Dutch auction is when it starts off at a high price, too high for anyone, and it goes down slowly, and then the first person to buy it gets it. Okay, so number one here, before we look at the data that we collected and start the analysis, let's make sure you understand the study design. So this is from 1A. Explain why the price should be analyzed using paired samples as opposed to two independent samples. So this is a question that should be review from section 8.1. And then part B, what makes it pair, is also kind of like reviewing that concept from 8.1 to a new scenario. Same with C and D. What's the explanatory variable? Is it categorical or quantitative? What is the response variable? Is it categorical or quantitative? So then for number 2, state the relevant hypothesis in words. We did a two-sided alternative, so let's review doing that. Number 3, define the parameter of interest and give the symbol that should be assigned to it. So here, the parameter of interest should probably be roughly the same symbol as the parameter of interest from your reading. So hopefully that helps. And then state the relevant hypothesis and symbols. Okay, so the data for the auction can be found in the file auction there. The selling prices for the Dutch auction are labeled Dutch, and the prices of the first price sealed bid are labeled FP. Paste this data into the match pairs applet. I have even better news for you. You just need to go to the applets link in Canvas, go to the match pairs applet, which is right here. And then you can even select the data from, it's at the top there. Okay, so there's the data. There's Dutch and FP. Okay, and then so there's no need to copy and paste it because it's in the applet. All right. Now, what is the sample mean price for the Dutch auction? So I'm going to delete a couple of these so that my answers are different from yours. Okay, use data. All right. So now I've deleted some things, so my data is different from yours. But so what is the sample mean price for the Dutch auction? So for the Dutch, my sample mean is 4.865. What is the sample mean price for the first price sealed bid auction? FP, 4.437 for me, a bit different from you. What is the mean standard deviation for the difference of the two prices? So that's going to be in black. The mean for the difference and the standard deviation for the difference. And then determine a p-value using the applet. Explain how you did so. Notice that the simulated, no, so that's, okay. Let's find the p-value then. So we'll randomize, and we will randomize it. You can do 1,000 times. I'm going to do 10,000 times because I know that my computer can handle it. Don't want to animate it. Randomize. It does take some time to do 10,000. There we go. And so then take my my observed difference, not distance, being that. I'll copy it and I'll paste it here. Make this match my alternative hypothesis. And I'm getting in the p-value of roughly 0. And then you should use full sentences because it's important to explain how you did so. Use full sentences. Okay? Now, validity conditions. The validity conditions for theory-based analysis of paired data. Theory-based methods of inference will work well for paired data. Let's shoot it over here. If the distribution of differences has a symmetric distribution, or if you have at least 20 pairs, i.e. at least 20 differences, and the distribution of the sample difference is not strongly skewed. This test is known as a paired t-test. So the thing we're looking for of being roughly symmetric is the black distribution here, the differences, because that's what we're doing stats on, is the differences. So even though let me go back to the original. So the original data is pretty skewed right and skewed right. They're skewed right in kind of the same ways because the distribution is fairly, like, it's not symmetric, but it's almost symmetric. So are the validity conditions met for these data? You can talk about the almost symmetricness of it, and you can also talk about how I've got way more than 20 pairs. So both, it works well. Okay, now we're going to go to the theory-based inference applet. So let's go back to our applets, theory-based, and then the scenario will be 1 mean, and then enter the sample size, sample mean, and standard deviation for the differences. So my numbers will be different from yours. So I'm going to enter 4.28. No, first my sample size is 83, different from yours. 4.28. 0.428. Yeah, 0.428. And then standard deviation 0.661 for me. Calculate. Okay. All right, check the box test of significance. And enter the information for the hypotheses. So we have a not equal to in our alternative hypothesis. And then calculate. All right. What is the value of a standardized statistic? So mine is that. Tell me yours for your answer. What does this number tell you? So the standardized statistic, the t here, is telling us how many standard deviations our sample is away from the 0, assuming the null hypothesis. All right, in light of the value of standardized statistic, do you expect the p-value to be small or not small? How are you deciding? Well, remember how strength of evidence, as the standardized statistic gets really big, we have stronger evidence, and as the p-value gets really small, we have stronger evidence, and so it makes sense that a p-value is that. Okay, what is the value of the p-value? Is it similar to p-value found using the simulation-based method? Mine is. Maybe, so tell me whether or not yours is the same or not. Okay, number 8. Recall that the theory-based inference applet can also produce confidence intervals to the parameter of interest. So go to the applet, check confidence interval. Okay. So report the 95% confidence interval. So mine is, remember that I deleted a couple things, so it's different from yours. So mine is this. So I would report those numbers. I could turn those into percentages. Maybe, no, don't turn them into percentages because they reference. But what units are these in? Well, my original numbers are in dollars, right? And so my confidence interval will then also be in dollars. So I can turn these into with dollar signs there. So interpreting that means writing a full sentence. We're 95% confident that the true difference between, make sure you say it right, because we're doing Dutch minus first past. Yep. Okay. So the true difference of Dutch minus first pass is between like 28.37 cents and 57.23 cents. Okay. Does the 95% confidence interval agree with your conclusion when using the p-value? How are you deciding? So it's always like the confidence interval. Remember how we calculate confidence intervals, like all the numbers that are plausible, meaning like all the numbers that if our sample had been inside there, then our p-value would have been small. But notice how zeros not in this confidence interval, and that's a key clue for how you answer that question. Okay, exploring further. Number 9, based on the analysis and number 7 and number 8, state your conclusion in the context of the study. Be sure to comment on statistical significance. Do the data provide evidence that selling cards in the Dutch auction differ when sold in the first price sealed bid auction on average? How are you deciding? So remember to use full sentences for this problem, and there's several parts. So like have at least one full sentence for each bullet point. So then estimation, find and interpret a 95% confidence interval. Causation, can you conclude a causation? If yes, what causes what? If not, how are you deciding? And then generalization, can you extend the results of the study? Other kinds of cards, other types of items, anything sold in auction format on the internet? How are you deciding? So for each bullet point, you should have at least one sentence, and some of them, you should have more than one sentence. Okay? That completes this section.